Jai Hind, dear student. Myself Aryan Jaiswal, Physics Department, Loyola High School, Patna. Before starting my lecture, I would like to advise you all. Please get ready with pen and papers and make a clear notes from my lecture.
Well, today we'll learn about electric field. As we have studied about Coulomb's law, there we used to find force of interaction between two charged bodies, although there was no contact between the charged body. It means Coulombic force is non-contact force. Therefore, here arises a question: how a charged body interact another charged body without coming in contact? And my answer is due to electric field. Let us define electric field. It is a region or surrounding of a charge throughout which an electric force can be experienced. Note, theoretically electric field of a charge can exist up to infinity. Let us introduce a physical quantity, electric field intensity. See, electric field and electric field intensity both are different things. Electric field is a phenomena while electric field intensity is a physical quantity which gives the idea of the strength of any electric field, and it is defined as electric force experienced by test charge inside the electric field region for a given position. In this definition, I have used test charge. So let us define test charge. It is the smallest positive charge. Q naught tends to 0. The test charge is denoted by Q naught, which cannot disturb the electric field region. Theoretically, we take it unit positive charge. One thing is very important. We do not take always unit positive charge. Only to derive the formula, we take test charge as a unit positive charge. If a test charge, let us suppose we place the test charge inside the electric field, so it will experience electric force. If Q naught test charge is placed inside the electric field and it experiences an electric force F, then electric field intensity denoted as E is equal to F by Q naught, where Q naught tends to 0. It is very clear from this relation. If I say electric field intensity is a vector physical quantity and force is also a vector physical quantity, and Q naught with the test charge, it is positive charge. So we can say the direction of electric field intensity will be same as the direction of force experienced by test charge. SI unit of electric field intensity can be written from this formula. Force, the SI unit of force is Newton and the SI unit of charge is Coulomb, so it can be written as Newton per Coulomb, and its dimensional formula is m and t to the power minus 3 a to the power minus 1. Now I will wish to find electric field due to point charge. Let us consider 2 point charges Q1 and Q2 has been placed at a separation R. If I find the force experienced by Q2 charge due to Q1, then it can be written as F21, and it will be 1 by 4 pi epsilon naught Q1 into Q2 by R square. This relation has been written with the help of Coulomb's law. If I assume Q2 be the test charge and Q1 be the source charge, then this force experienced by this charge will turn into electric field intensity. See here, if Q1 tends to 0, point source charge, and Q2 tends to Q naught. Q2 tends to Q0. This is test charge. Then F12 vector tends to E vector. If you write it in a scalar form, then F12 tends to E, and E can be written as 1 by 4 pi epsilon naught into Q by R square. This is electric field intensity, right? Here we can say from this formula electric field intensity is directly proportional to Q, and electric field intensity is inversely proportional to the square of separation between the source charge and point of observation. So from this concept we have concluded that if R is increasing, then electric field intensity will decrease. Implies that if R tends to infinity, then E tends to 0. So we can say theoretically electric field can exist up to infinity. Second thing, if R is decreasing, then electric field intensity will increase. Implies that R tends to 0, then E tends to infinity. One thing is very important. What happened if R will be 0? Then this will be undefined. So we can say where their source charge has been placed, at that point we can't find electric field intensity, right? So electric field intensity is a vector physical quantity. So we must learn how to find the direction of electric field intensity. So vector form of electric field intensity. Let us suppose there is a Q positive charge and it is a point charge, and we wish to find electric field intensity at any point P, which is at a distance R from the source charge. So this is positive charge and this is also a positive charge, because test charge is always positive charge. So force experienced by this test charge is known as electric field intensity, and we can write this formula, but we have to express it in vector form. So E vector is equal to 1 by 4 pi epsilon naught Q by R square. And if we say AP is a R vector, so we can write it E vector is equal to 1 by 4 pi epsilon naught into Q by R square into R cap. जैसा कि हमको पता है, अगर किसी वेक्टर को रिप्रेजेंट करना है उसकी डायरेक्शन को, तो हम किसका हेल्प लेते हैं? यूनिट वेक्टर का। ये आर वेक्टर था, इस यूनिट वेक्टर से मैंने मल्टीप्लाई कर दिया तो ई किस में कन्वर्ट हो गया? वेक्टर में। अब यूनिट वेक्टर को हम लिखना जानते हैं, अगर कोई पूछे आर कैप इज इक्वल टू व्हाट, देन आर वेक्टर बाय आर. सो दिस एक्सप्रेशन कैन बी रिटन एज 1 by 4 pi epsilon naught into q by r square into r vector by r. Finally, in vector form we can write it E vector is equal to 1 by 4 pi epsilon naught q by r cube into r vector. If I wish to explain the same phenomena for negative point charge, so here we see this is negative charge and this is test charge. So there will be force of attraction. In this case, electric field will directed from P to A, while in this case, electric field is directed from A to P. And this expression can be written as 1 by 4 pi epsilon naught into q by rq minus r vectors. So from these 2 points, we have concluded that electric field intensity always directed away from the positive point charge, while electric field intensity always directed towards negative point charge. So we have the mathematical formula of electric field intensity. So we should draw a graph, electric field versus separation. Okay. So let us draw a graph for positive point charge. See, as we move away from this point charge, then the strength of electric field intensity will decrease, right? And if we take a point right side from this side, so in this case the direction of electric field will be towards right. So you can write it because y is equal to 1 by x square के लिए एक ग्राफ होता है. If you take any point this left side, so in this case direction of electric field towards left. So this will be right, because y, if y is equal to 1 by minus x square, so this will be the curve. In same manner, if we wish to write the variation of electric field intensity for negative charge. So if you take any point, right side of this point charge, okay, so in this case electric field will directed towards left, means left negative direction, so negative, this is negative axis, so in this case this will be for negative axis and this will be for positive. Why? So if you take any point in left side of this point charge, in this case electric field will directed towards right, so towards right means positive axis. So this is the graph. See, this line will never touch this vertical line. Why? Because for r is equal to 0, electric field intensity is not defined. Right. Now we have learned to find electric field intensity due to point charge. So let us consider some important point regarding electric field intensity. Point first is electrostatic electric field is a conservative field. Yes. Here I have written electrostatic electric field. Means वो इलेक्ट्रिक फील्ड जो रेस्ट चार्ज की वजह से अगर प्रोड्यूस किया गया है वो कंजर्वेटिव इन नेचर होगा. एंड यू नो वेरी वेल अबाउट कंजर्वेटिव फील्ड. कंजर्वेटिव फील्ड इज पॉइंट फंक्शन. सो वर्क डन इन अ क्लोज पाथ इज रिमेन 0. Second point is electric field intensity at a point due to a fixed point charge cannot change due to presence of other charges, but net electric field intensity can change. अगर कोई एक पॉइंट चार्ज है, दूसरे पॉइंट पर अगर उसकी वजह से हम लोग इलेक्ट्रिक फील्ड इंटेंसिटी कैलकुलेट करते हैं तो हमको एक वैल्यू मिला है. अगर उस सराउंडिंग में और कोई चार्ज रखा जाए तो इसके द्वारा जो इलेक्ट्रिक फील्ड प्रोड्यूस हो रहा है वो चेंज कभी भी नहीं होगा. यस, नेट इलेक्ट्रिक फील्ड इंटेंसिटी कैन चेंज. सो टू फाइंड द नेट इलेक्ट्रिक फील्ड इंटेंसिटी वी विल स्टडी सुपरपोजिशन थ्योरम. एंड अकॉर्डिंग टू सुपरपोजिशन थ्योरम, इफ देयर आर मोर देन one charges in the surrounding and you have to find electric field intensity at a point, then we will find the vector sum of all electric field intensity, and that is called superposition theorem. If a point charge Q has been placed inside an electric field of a strength E, then it will experience a force, and the force experienced by the charged particle F can be related as F vector is equal to Q into E. So this is vector and this is vector, so we can find the direction. If Q be the positive charge, then the electric force experienced by the charge is directed in the same direction as electric field. So here electric field intensity and electric force both will be parallel. If this charge is negative, then the direction of this electric force is directly opposite to the electric field intensity. So let us discuss some numerical problem related to electric field. There is a point charge. There is a point charge. You have a situation. There is a point charge and which is at rest just above the earth's surface and having mass is small m and q. Then we have to find the magnitude and direction of electric field intensity present there. Okay. Now see the situation. This charged particle is experiencing a force in vertically downward direction, that is gravitational force mg. Also this mass should fall in vertically downward direction, but it is not happening because of electric force. If there is an electric force and this is acting in vertically upward direction and net force acting on this system is 0, then it can be in rest, and same question is asking. So क्या करेंगे? इलेक्ट्रिक फोर्स ऊपर के तरफ, ग्रेविटेशनल फोर्स नीचे. अब क्या मैं कहता हूं कि वर्टिकली अपवर्ड डायरेक्शन में मैं ऐसा मान रहा हूं इस तरीके से यहाँ पर इलेक्ट्रिक फील्ड है और जिसका स्ट्रेंथ क्या है E. तो अब ई है तो एफ ई का वैल्यू कितना हो जाएगा भाई, एफ ई का वैल्यू हो जाएगा क्यू इंटू ई, जैसा कि मैंने अभी बताया। सो इस पर लगने वाला नेट फोर्स अगर हम देखें तो अकॉर्डिंग टू क्वेश्चन इस पर लगने वाला नेट फोर्स क्या है, जीरो। वर्टिकली अपवर्ड डायरेक्शन में फोर्स लग रहा है एफ ई एंड डाउनवर्ड डायरेक्शन में फोर्स लग रहा है एम जी इज इक्वल टू जीरो, राइट। सो वी कैन राइट हियर q into e minus mg is equal to 0, so we can find the value of e and it will be mg by q. Now if we talk about direction, so this is positive charge. So positive charge अगर किसी इलेक्ट्रिक फील्ड में रखा गया है तो जो इलेक्ट्रिक फील्ड का डायरेक्शन होगा वही इलेक्ट्रिक फोर्स का होगा, अभी मैंने बताया। इसका मतलब इलेक्ट्रिक फील्ड कैसे है, वर्टिकली अपवर्ड डायरेक्शन में, इसको हम लोग ऐसे लिख सकते हैं, राइट। अब इसमें एक सेकेंड क्वेश्चन और मेरे से पूछा जा रहा है, अगर मैं इस क्यू चार्ज के जगह पर, अगर ये क्यू चार्ज है इसके जगह पर सेम मैग्नीट्यूड का माइनस क्यू चार्ज रख देता हूं, तो बताओ कि इस चार्ज पार्टिकल का एक्सेलरेशन क्या होगा और किस डायरेक्शन में होगा। सिचुएशन को हम लोग देखते हैं। जैसे ही अगर हम इसमें नेगेटिव चार्ज रखेंगे तो इस पर दो तरह का, ये अर्थ है हमारा, ये अर्थ है, तो एक तो फोर्स पहले से लग रहा था ग्रेविटेशनल फोर्स, और एक फोर्स और लगेगा, वो क्या लगेगा भाई, वो लगेगा इलेक्ट्रोस्टैटिक्स फोर्स। सो एफ नेट इज इक्वल टू व्हाट, एफ नेट इज इक्वल टू व्हाट, ये हो जाएगा एफ ई प्लस एम जी, और इसका वैल्यू यहां से हम देखें एफ ई माइनस एम जी इज इक्वल टू जीरो, सो एफ ई का वैल्यू क्या हो जाएगा, एम जी। सो हम लिख सकते हैं एम जी प्लस एम जी, ये हो गया एफ नेट, इसको हम लिख सकते हैं टू एम जी। फ्रॉम न्यूटन सेकेंड लॉ ऑफ मोशन एफ नेट इज इक्वल टू मास इंटू एक्सेलरेशन। सो एक्सेलरेशन इज इक्वल टू व्हाट, एफ नेट बाई एम, एफ नेट का वैल्यू क्या है, टू एम जी बाई एम। सो इसका एक्सेलरेशन क्या हो जाएगा, टू जी, वर्टिकली डाउनवर्ड डायरेक्शन में। फिर से मैं डिस्कस कर देता हूँ इस क्वेश्चन को। मेरे पास एक सिचुएशन था कि एक चार्ज पार्टिकल है जिसका मास m है, उसमें चार्ज q है, इसको अर्थ से जस्ट ऊपर रखा गया है और ये स्टेशनरी है, रुका हुआ है। इसका मतलब इस पर लगने वाला नेट फोर्स क्या है, जीरो। तो नीचे की तरफ फोर्स क्या लग रहा था, mg। इसका मतलब इलेक्ट्रिक फील्ड कैसे होना चाहिए, ऊपर की तरफ, क्योंकि ये चार्ज कैसा है, पॉजिटिव, तभी तो ऊपर की तरफ फोर्स लगेगा। सो इस पर नेट फोर्स क्या होना चाहिए, जीरो। यहाँ से हमें एफ ई माइनस एम जी इक्वल टू जीरो तक रिलेशन मिल सकता था, बट इस क्वेश्चन में हमें क्या निकालना था, ई वेक्टर। ई वेक्टर बराबर क्या हो जाएगा, एम जी बाई क्यू, वर्टिकली अपवर्ड डायरेक्शन में। लेकिन क्वेश्चन अब चेंज करता है, कहता है कि इस क्यू के जगह पर माइनस क्यू रख दे, तो बताओ इसका एक्सेलरेशन क्या होगा। अब जैसे ही इस पर माइनस क्यू रखेंगे तो जब नेगेटिव चार्ज को किसी इलेक्ट्रिक फील्ड में रखते हैं तो उस पर जो इलेक्ट्रिक फोर्स लगता है इलेक्ट्रिक फील्ड के अपोजिट डायरेक्शन में लगता है, तो इस वर्टिकली डाउनवर्ड डायरेक्शन में दो फोर्स लगेंगे। सो एफ नेट इज इक्वल टू एफ ई प्लस एम जी, एंड ये क्या हो जाएगा, टू एम जी। नाउ फ्रॉम न्यूटन सेकेंड लॉ ऑफ मोशन वी कैन राइट एफ नेट इज इक्वल टू मास इनटू एक्सेलरेशन। सो ए इज इक्वल टू एफ नेट बाई एम, और एफ नेट का वैल्यू कितना है, टू एम जी। सो हियर we have 2g acceleration in vertically downward direction. Now we have some problem, this is also called symmetric problem. See, if there are case of regular polygon, if there are case of regular polygon and equal charges has been placed at the vertices of the regular polygon, the net electric field intensity at the center of the regular polygon is remain zero. Let us suppose this is a regular polygon of three sides, that is called equilateral triangle, and here equal charges have been placed at its center. So net electric field intensity E net at its center is equal to zero. In same manner, this is a square, it has four sides. So net electric field intensity at its center is equal to 0. Also the net electric field intensity at the center of regular hexagon is equal to 0. There may be n side, right? So let us try to understand the phenomena. See, This charge will produce electric field and it will go in vertically downward direction, in this direction. And this charge also produce electric field intensity. This will go here, and this charge also produce electric field, and this will go here. What we have seen, these three vectors are acting at the center, and all vectors have equal magnitude. Why equal magnitude? There are same charges and same separation, right? So we know from polygon law of vector addition, if there are coplanar vectors, n coplanar vectors acting at a point, and at angle between the adjacent vector is remain same, then net resultant of the vector is 0. So here 120 degree, 120 degree and 120 degree. That's why net electric field intensity is 0. See here, due to this electric field intensity will be here, due to this electric field intensity will be here, due to this electric field intensity will be here, and due to this electric field intensity will be here. So there are 4 different electric field intensity. All have equal magnitude and angle between the adjacent electric field vector is same. So net electric field intensity will be 0. Also we can understand it in another way. Suppose that these two vectors are collinear, so these are equal in magnitude, so they get cancelled. Also they get cancelled. Net electric field intensity will be 0. Okay, there may be n sides, and we will solve the question in the same manner. Now there arises a situation. This is the case of regular polygon. Suppose that a square, and here is q charge, here is q charge, here is q charge. Now we have to find electric field intensity at the center, right? If I say the age of this square is A, so what will be electric field intensity at the center? Now see, due to this electric field intensity will be here, while due to this charges electric field intensity will be here. These two electric field intensity will get cancelled because magnitude will remain same. Now due to this charge electric field will be here, but there is no charge, so here net electric field intensity will be K Q by distance. See, side of the square is A, so diagonal will be A by root 2. Now separation is half, then we will square it. So what will be 2kq by 2a, sorry, 4kq by 2a square. So we can write it 2kq by a square. Now next question. There are 4-point charges and has been placed at the vertices of a square of side a root 2, and the charges are q minus 2q plus 3q and minus 4q. Then we have to find net electric field intensity at center. Find E net at center. See? Now let us draw the diagram. This is positive charge, so electric field due to this charge will be here in this direction, that is called EA. Once again, electric field due to this charge, this is negative charge, and as we know the direction of electric field directed towards the negative charge while away from the positive charge. So due to this charge will be here, that is called EB. Now due to this charge, this will be here, that is called EC, and due to this negative charge electric field intensity will be here, that is called EC. So net electric field intensity will be what? E net is equal to EA vector plus EB vector plus EC vector plus ED vector. Okay. There are many ways to find the resultant of these four vectors. We can use resolution of vector. We can use polygon law of vector addition. We can use parallelogram law of vector addition. And I think you are very expert in finding the resultant vector. So we can use any method, right? See, these two vectors are collinear. So make a pair of collinear vector. EA vector plus EC vector and EB vector plus ED vector, right? Let this is equal to A vector and this is equal to B vector. So let us find the value of A vector and B vector. Okay? So A vector is equal to what? EA vector. If I suppose this is negative direction and this is positive direction. In the same manner, I suppose this is negative direction and this is positive. We can assume any direction positive or any direction negative. It totally depends on us, right? So A vector can be written as, what will be value of A? K, Q. What will be this separation? So side of this square is A root 2. So diagonal is equal to what? A root 2 into root 2. So what will be this? 2A. Now half distance will be D by 2 is equal to A. So we can write it KQ by A square. Now this A has been taken as negative. Now EC will be what? It has positive sign. K, what will be charge? 3Q by A square. So we can write it 2K Q by A square. And it is directed from B, directed from C to A. See? Now we just find B vector and EB vector will be, this is due to minus 2Q charge. Then it has been taken as negative sign, minus K into 2Q by A square. And due to this charge, it has been taken as sign positive, plus K into 4Q by A square. So it can be written as 2KQ by A square. What will be direction of B vector? It is directed from B to D. Now what we have observed that if I say A vector is acting in this direction, that is A vector, and B vector is acting in this direction, and the angle between these two vectors is 90 degree. So E net will be what? It will be, magnitude of E vector will be A square plus B square. Why? Because these two vectors are perpendicular. So we can write it 2KQ by A square into root 2. And what should be direction of the net electric field intensity, right? The magnitude of A vector and the magnitude of B vector are remain same. So net electric field will go from midline in this way. So this is the direction of E net. Okay.